Hello everyone, welcome back again. So this is a continuation from where we ended. So this is part B3 of Chemistry 2017 past paper revision. Alright, so before we get to it, don't forget to hit that like button and subscribe. Alright, so B3 says beryllium burns in fluorine to form a white solid called beryllium fluoride. So with that in mind, we need to understand that beryllium and fluorine are two separate elements. So in beryllium burns in fluorine to form a white solid being called the beryllium what? Fluoride. Now we're being asked to name the type of bonding in beryllium fluoride. Now let's get to understand that when it comes to bonding, we are just talking about the attraction of what? Atoms. So atoms will always want to bond with one another in order to be stable. So in order for us to know the type of bonding that is taking place in every other could be a mixture or a compound, we just have to identify the elements present within that particular compound. You have to look at beryllium and also look at fluorine. So you need to check what beryllium is and what fluorine is. What element is beryllium and what element is what? Fluorine. Now in this case, if you look at the elements we have, the type of bonding that we can choose from what has been given will be what? Ionic bonding. Now, ionic bonding is not the only type of bonding we have. We have molecular type of bonding. We have the same ionic bonding as well as metallic type of bond. So all those are some of the many examples, or let me say the common bondings we have. So let us understand that if you look at beryllium is in group 2, while fluorine is in group 7. So you're looking at a metal reacting with a non-metal. And as a result, that is what we call an ionic type of bonding. So the type of bonding present is ionic. Others would like to term it as electrovalent bonding. So you could either say electrovalent bonding or simply just ionic bonding. Now B says in a space below, draw a dot and cross diagram to show the bonding in beryllium fluoride. Show all electrons. Alright, so in order to do this, we need first to understand how many electrons are present in beryllium. So we have beryllium. So beryllium has the mass number of 4 and the electron number of, the mass number of 9 and electron number of 4. So we basically have 4 electrons in beryllium, while we have 9 electrons in what? Fluorine. So the electronic configuration of beryllium would be 2, 2, while the electronic configuration of fluorine will simply be 2, if you remove 2 from 9, you get 7. So how are we going to draw the bonding structure for beryllium and fluorine? Now we need to do a crisscross where we write the valency of each particular element in order to know the type of compound that we formed. We know it's beryllium fluoride, but if we get beryllium and fluorine, the valency is determined by knowing the group in which the element belongs. Beryllium belongs in group 2, so it has a valency of 2, while fluorine is in group 7, and if you reach group 4 to 7 or 8, you literally have to subtract from 8. So in group 7, you say 8 minus 7, you get a valency of 1. You do your crisscross, that goes there. So you have beryllium 1 and fluorine 2. This is how the compound of beryllium fluoride is written. Now, once you have that, this will tell you how many atoms of beryllium and how many atoms of fluorine should be drawn. So you know that you draw 1 atom of beryllium and 2 atoms of fluorine. Now you know that beryllium needs to lose 2 electrons to be stable, while fluorine needs to gain, since we have 2 fluorine atoms, fluorine 1 and fluorine 2, each fluorine atom needs to gain 1 electron to be what? Stable. But the beryllium atom that you have needs to lose what? 2 electrons to be what? To be stable. So what are we supposed to do now? So in our case, we're going to have a transfer of electrons from these individual elements. So beryllium will transfer 2 electrons. One will go to the first fluorine and the other will go to the second fluorine, because it's easier to lose 2 than 7. Let's be mindful about that. So if we draw a beryllium structure, or find a structure for beryllium, we just have one shell, then inside you can write beryllium, and since beryllium is a metal, we use crosses for metals, and I can give you the shell like that, a bracket type of enclosure to show that it's beryllium as an individual atom. Then it's losing 2, and whenever something loses, you always put a plus sign. So you said 2 plus. Now each fluorine atom has to gain how many to be stable? It has to gain 1 to be stable. So remember, it's supposed to be 2,8. So what we're going to do is, we know that each fluorine has to gain 1, so we draw the structure. So if we want, you can just draw the final structure. Let's just draw the outer structure, or everything if we want. Let's just draw everything. So we know that the inner electrons will just be the dots, so that's the first fluorine, and we have 1. Initially we had 7, so we have 1, 2, 3, 4, 5, 6, 7, and then the last one will be as a result of being transferred by beryllium to one of the fluorine atoms. So I put the cross like that, so we know that this electron is coming from beryllium, so it's going to be a minus. Then I'll do the same thing for the other fluorine, the inner structure, shell, and the outer shell. So we have that, so we can put a minus as well. So say fluorine, so 1, 2, remember initially we have 7, 1, 2, 3, 4, 5, 6, 7, then 1 from beryllium, put a cross like that. Then remember our chemical formula is simply BeF sub 2. So this is beryllium fluoride. So that's how you go about drawing your bonds. Just remember first to write the electronic configuration, then know the chemical formula to know the atoms present, and just do the transfer of electrons. Now suggest any 2 physical properties of compounds that have similar bonding as beryllium fluoride. So all ionic compounds have these physical properties that we need to understand. The first physical property that we need to know is that all ionic compounds are able to conduct electricity in molten or aqueous state. When we say aqueous state, it means that the compound has simply been dissolved in water. If you look at the most basic compound, which is sodium chloride, the common table salt, when you dissolve sodium chloride in water, it becomes aqueous sodium chloride, and it will then conduct electricity. So all ionic compounds are able to conduct electricity in molten state. So they conduct electricity in molten state or aqueous state. Then the other physical property is that they are generally soluble. When you say soluble, it means that they're able to dissolve in polar substances such as water. When you talk about substances that are polar, we're talking about those solvents that are polar. So they can dissolve in polar solvents. An example I can give is basically water. So that's how you go about solving this question. There is a quite number of questions that involve bonding. I know bonding could be a bit of a handful to most students, but I know at first glance it might be that much of a lot of working, but with a little bit of practice, you'll get a hang of it. Alright, let's move on to the second. When I say not second, why am I always messing up? Should be the 4th question. Alright, don't forget to hit that like button and subscribe.